Final example, what is the degree of y equals negative 2x squared plus 4, all that to the 407? Now you see this at first and you might freak out because you're like, I can't possibly expand 407 times. I can't do that. But don't worry, all they asked for was the degree, right? So notice, if I've got quantity x squared plus 3 times quantity x to the 5th plus 48, do I have to look at anything else to figure out what the degree is going to be other than the front parts? No, because I know only the x squared and the x fifth are going to come together to make x to the 7th. And there's going to be other stuff, but I know I can't get any higher exponents out of this than the x to the 7th. It's going to be the leading term that will have the highest exponent. It's going to be the exact same thing on this one. It's going to be that negative 2x squared. It's a question of how many times does negative 2x squared hit negative 2x squared, right? That's the only thing that's going to be able to really bring increases to the degree. There's going to be a whole bunch of other stuff, but we're not concerned with it because all they asked for was the degree. So it's going to be negative 2x squared raised to the 407 plus other stuff. But we don't care about the other stuff. So negative 2x squared plus 407, well, we distribute that negative 2 to the 407, x squared to the 407. So if we've got 407 x squareds, then it's x squared times x squared times x squared times x squared. So it's going to be the same thing as x to the 2 times 407, because they're going to iterate that many times. It's going to hit that many times. So we've got negative 2, 407 times x to the 2 times 407. So negative 2 to the 407 times x 814, x to the 814. So our degree is n equals 814. That is our degree for this polynomial. Now, as x goes very far to the left, x goes to negative infinity. Will y go up or down? Y approaches positive infinity or y approaches negative infinity? And then what about as x goes very far to the right, as x goes to positive infinity? So to do that, we need the leading coefficient test, right? So leading coefficient test. So at this point, we already know what the degree of this polynomial is, right? This polynomial is n equals 814, so it is an even degree polynomial. Now we want to figure out what is our leading coefficient. Is it positive or negative? So plus or minus. We do that, negative 2 to the 407 times x to the 814. Well, if it's negative raised to an even number, they'll all get canceled out. If it's negative raised to an odd number, one of them remains because it will wind up getting to stick around. All of the even part will get canceled out, but that odd is an extra plus 1, so it sticks around. So we'll get negative 2 to the 407 times x to the 814. That means we've got a negative sign right here. So by the leading coefficient test, we've got negative and even. So negative and even means an even one. Even normally goes in the same way that a parabola goes, cups up normally. So even at positive, but even at negative, we'll flip that cupping shape and we'll get that. Now, of course, we don't actually know what's in the middle. All we know is the extremes, because that's all we were guaranteed from the leading coefficient test. But that's all we have to figure out because it's as x approaches negative infinity. So from this, we see even as it goes negative, we go down on the left, down on the right. So as x approaches the negative infinity, as x goes very far to the left, we're going to approach y going to negative infinity. As x goes very far to the right, x goes to infinity, we're going to get y going to negative infinity once again. All right, great. Leading coefficient test to be able to figure that out. All right, we'll see you at Educator.com later. Next time we'll look at roots and zeros of polynomials and get a really good understanding of how these things are working. All right, bye.